Hello everyone, welcome back to the channel. So in this tutorial, we'll discuss something that is revolutionizing the character animation, especially the gameplay animation, motion matching. So what is motion matching? So unlike our traditional state machines where we have predefined animation graph, animation blend spaces and blend times, motion matching doesn't rely on that. But instead it treats your animation as a database at runtime and pick the best frame to play at a specific time using a query which we run at runtime. So in that query we provide the, let's say, character trajectory where the character is heading, different bones position, for example the left foot, right foot bone position, and based on that query it gives us the best suitable pose which should be run at that specific time. And the result of that is a seamless transitions all over the places. No matter what our character is doing, what the input is, we have a seamless transition all over the place. So in this tutorial series, we'll start completely from scratch and gradually build the system step by step so that we can understand how motion matching works under the hood and how we can implement and why we need to use it for our in the animation and the project. The animation blueprint is completely empty. I'm using the same, by the way, character blueprint. This is the same character blueprint which comes with the game animation sample. And another thing is I have exported all the animations like idle, run, walk, sprint. These are all the animations in the project. So the first thing you need to do is before starting the motion matching, you need to enable the desired plugins. So we need PoseSearch plugin, motion matching, motion warping, and animation locomotion library. So you can find all the plugins inside the plugins tab. So this is the locomotion library. We need the choosers as well. This is the motion trajectory, motion warping, a PoseSearch, and if you search for chooser, we need chooser as well. So these are the few plugins which we need before starting. Okay, considering all the project is ready, you have all the animation blueprint, and the plugins are enabled. So now let's get right into it. I'm gonna go to the event graph and I'm gonna delete all these functionality. And so first thing we need to do is need an event on blueprint initialize event initialize animation. So this will be the event which runs when the animation instance, you can call it as a begin play. So I'm going to call it try get pawn owner, and I'm going to cast it to sandbox character. So now I'm going to promote this character to a variable. I'm going to call this player character. We need a reference to our character movement component. I'm going to get the character movement component. I'm going to also promote this to a character movement player CMC, player character movement component. I'm going to add it to the category of references. So this is the character movement component and player character reference are set up. I'm gonna now need a update animation, blueprint update animation, and I'm gonna check if my player character is valid. If is valid, then we will run the logic. So I'm going to promote to a variable is layer valid. Okay, so now we need first of all we need the trajectory so that we can see where our trajectory is heading, what is the input value. So in order to get our trajectory, I'm gonna create a new function. I'm gonna call this update trajectory. This will be our thread save. I'm gonna search for PoseSearch generate trajectory for character. The animation instance will be our current animation instance. Get owning component and anim instance, which is reference to self. For trajectory data, I'm gonna promote it to a variable. I'm gonna call this trajectory data, and the category will be trajectory related variable will always be in the same category. Delta time, same access delta seconds. So this will be our trajectory. We need to pass it as a reference, and then it will give us the output variable trajectory. Set this to trajectory data category. Last update controller, yeah, the last update, I'm gonna set it to 0. Okay, so this will give us the trajectory output, and we need it inside our trajectory to set this variable to true. I'm gonna call this last desired your last update. I'm gonna put it to the trajectory as it is. So now, in order to get our trajectory working, we need a thread save function. I'm gonna override the blueprint thread save update animation, and first of all we need to check if our player is valid. So if our player is valid, then we run this function update trajectory. This should be category also trajectory. Okay, so in order to debug our trajectory, so what we need a PoseSearch node inside our animation graph. So what I'm gonna do is add a PoseSearch node, sorry, pose history node. So the sampling interval, this will tell us how often we will call this, like get the how often we run the query for selecting the pose. This will be 0 means at every frame. These are the collected bounds which we need to match the pose against. We need foot L, foot R, our thigh bone, thigh left and thigh right. So these are our bones, and I'm going to add a new another one which will be our pelvis. So our bones are set up. We need to initialize with reference pose, set it to true, and now we need to pass the trajectory which we have just calculated. I'm going to set it the variable to trajectory itself. Now when I hit play, and you will see we have a trajectory. So in order to see the trajectory, you need to enable it from the trajectory sample. Sorry, we have the animation widgets, and inside we have this trajectory enabled. So if you don't have this widget, this is a simple command. So if I open this preview, we'll see trajectory graph. There is a command a.anim node something, a.anim node, a.anim node dot pose history debug, draw debug trajectory. We can use that. So Our trajectory is now working. So we need to set the parameters for our trajectory. Let's say we need to set the sampling to -1 and the history count. We need the history count of 30. So if I now hit A, you can see we have the history count, which represents as a red mark. So this is the history count, and the sampling interval currently set to 0.2. Sampling interval are the blue intervals you can see for our trajectory. I'm going to set it to 0.1 so that these are more these are less distance from each other. And the trajectory count, I'm going to set it to 15. And currently you can see if I slightly move my mouse, the trajectory just snap to the input. So we don't want that. In order to reduce that, we need to set the trajectory data and set the rotate towards movement speed to 0. So now if I hit play, you can see we still have this. So we need to set it to both at 0. Now you can see if I move my mouse left and right, we have the trajectory which is not snapping. So this is our trajectory is done. Now let's set up the remaining assets. So now our trajectory is done. Let's go back to the content browser, and I'm gonna go to the animations folder. We need the motion matching data assets now. So I'm gonna create a new folder. I'm gonna call this motion matching data assets. So inside motion matching data assets, first thing we need is schemas, databases, and choosers. These are the few things we need. So the choosers. So the choosers are, first we need a PoseSearch. We need a schema first of all. So as you can see, the PoseSearch schema asset is your store the motion matching configuration and query settings. So motion matching configurations contains our trajectory, our different bones position, velocity. So we will store these information inside our schema. So I'm gonna create a new variable folder. I'm gonna call it schemas. Our first schema will be, we need to go to animation, motion matching, and PoseSearch schema. Select the mannequin PSS_default. So this will be the default schema which we can use for different databases. But we need a different schema. Let's say schema for our stopping, which have the higher rate of our trajectory, which a schema for our turning place. So that would require a different schema. So for most of the part, default schema works fine. We'll set the category properties in a bit. So in order to debug the schema, we need a database as well. So I'm gonna create a new folder. I'm gonna call this databases. Inside database, animation, motion matching, PoseSearch database. So for PoseSearch database, first we need to select the schema which we need to match the query against. This will be the schema PoseSearch database underscore, let's say our run starts. I'm going to open it up, and we need to place our assets. So we can place sequences, blend spaces, composite montages, and stuff like that. I think that's this covers all. I'm gonna go to the animation, run animations. Let's say I will grab all my run starts. Sorry, I'm gonna grab these starts. Start. So these are my run stars. It contains strafing, forward facing as well. Okay, I'm gonna place these into my PoseSearch database. There we go. I think we should go one by one, let's say. I'm gonna delete all these. First we need, we'll place the strafe related stars. Strafe star, wait. So let's use the normal stars. We'll use the reface later. I will show you guys what is the difference between these. So I'm gonna grab the start, backward, left, forward, left, right, neutral. I'm gonna grab all of these and put it into the database. So for example, these are our few stars. This is the default schema which run on our database by default. Forward, left, right. So let's say we don't need the hip switches, so I will exclude these. We need this animation start without hip switch, so we don't need this hip switch animation, let's say, so that we only have the hip switch when we are running on right diagonal. So I'm going to remove this. I'm going to remove this as well. So we only need right at this when we are not hip switching. Actually, what I will do is I'm gonna grab all this, put it in the database. I will show you guys how to set these notifies to set the weight of the animation, so that let's say we have this left start, we have this animation as well and this animation as well. So we will use animation notify states to put the extra weight, continuous extra weight on side to these animations, so that motion matching prefer to select these animation first as compared to the other ones. So I will use all these animation and will use animation notify states to prefer the animations. I'm going to select all the animations, go to the selection detail, disable reselection to true. I don't want them to reselect. So now let's first set up the schema. So our schema, first thing we need to data preprocessor. I'm going to set it to normalize with common schema. So these are our different channels. Our first channel is the trajectory channel. The by default weight is 7, which is too high, so I'm gonna set the weight to 1. So it contains different samples, like if I show in the database, so this is the trajectory samples, red one, blue this point, this, so these are 4 different points. So for the first sample I need the history pose -0.05, position XY, I'm gonna set the weight to default. For the second one, everything will be default except the weight, set it to 1. For the third one, the offset in the future, we see in the future. So this is the trajectory. We sample it in the future. So 0.35. This is the 0th point. This will be the 0.35 in the future. Set the weight to 1. 0.7 second in future, set the weight to 1, and I'm gonna add a new one, duplicate, and this will be the 1 second in future, and only prefer our velocity direction. I'm gonna set the offset to 1 and weight to, let's say, 1.5. So I am preferring my future velocity, future trajectory. Let's say I am my character is quickly snapping the input. I am preferring my trajectory to quickly select the animation which have changing directions. So these are the trajectory samples is done. For the second thing, we can only live with that for trajectory, but we need, for better animation blending, we need to consider our bones, like our current pose and our future pose, so that the poses are more kind of similar, so that they blend with each other. So in order to add an extra property, trajectory is one. For the second property, we need to we can use the position of different bones, velocity of different bones. So I'm going to use a group channel. First one will be our position channel. So for position channel, we need the bone foot L to foot R. Just a moment. I'm going to set the weight to 1. So these are all the default properties. So if I select save now, you can see these are two points on my feeds. So we are comparing these feed position as well when we are running the query to select the best suitable pose. First thing, we are using trajectory. Second thing, we are using the bone position, and the next thing we can add is bone velocity, so that we have always the best suitable pose which blends perfectly well. So position channel is done. I'm gonna add in 2 new channel, one for velocity foot left and one for velocity foot right. Foot L velocity and foot R velocity. Now you can see we have the feet velocity are in green. You can see my feet is heading in this direction, my velocity is in that direction as well. So now we need to put the weights, like let's say we have the default weights to 1 for each of the channel. So how we want to prefer our pose? Let's say we want the position to be in preference as compared to the velocity. So we set the weight to 1, and we want the velocity, and we set it to 0.3 weight for both, so that we prefer the bone position but also consider the velocity as well. So the weights are representing the preferences. So these are the weights which we are defined. Trajectory is done, weights are done, and position channel is done. So now we have the information stored for each data, for each animation. You can see we have the trajectory stored for each animation. We have the bone position stored for each animation, bone velocities stored for each animation. So now when we run the query, let's say our character is running, when we run the query to give the next pose, first we check our trajectory. If our trajectory is this direction, we will remain in this direction. We will select this animation, and then we will select our bones position, and based on that we are getting our next poses. Okay, so there are a few properties inside the PoseSearch databases. Continuous post cost bias. Let me open the nodes. So if I hover over the property, you can see this allow us user to play cost bias. So this will so if the values so in short, if we set this value to negative numbers, the motion matching system will prefer to select the same animations, so that our system don't jump over the multiple animations. As you can see, this is useful to help system to stay in one animation segment for longer period of time. This is useful so that our system don't jump over multiple animations too often. So that's why the default value is 0.01. I'm gonna prefer to stay in single animation as long as I can, so that in order to do that, I will set the cost bias to negative 0.5, negative 0.05. So with this way, I am preferring my animation to be remained to select the same animation. Next thing is normalization set. We need to create this set as well. You can see the property as well. So the optional database you want to normalize, without it difficult to compare costs for separated normalized databases. So we are separating our databases like run starts, run stops, loops, pivots. We have multiple databases. We are not putting all our animations in a single database. That is not the suitable way for achieving the motion matching inside Unreal, as according to Epic. So we are splitting the animations into databases, and we will put all the databases into a normalization set, so that we can compare with each database cost value. So I'm gonna go to the motion matching data assets. Oh wait, I will put this folder in this animation. Okay, animation motion matching data assets. Okay, so database, I'm gonna create a new motion matching normalization set. So in this set, we are storing all our databases into this set. PoseSearch normalize into all PoseSearch normalization set. That's it. Currently, we have only one database. We are set it to run starts. Okay. So our database done, PoseSearch schema done, and normalization. So now we need to run, we need to check our motion matching to run in a game. So in order to do that, let's say I'm gonna add a motion matching node. This is the motion matching node. For the properties, first of all, so let's by default, I'm gonna select this to run start and see if we have something. You can see. As you can see, when I release the input, my character is just stuck in the run start because we don't have any idle animation currently set up. Now when I move left, you can see we pick different animations. See? Okay, so this is functional. Now we need is, I'm gonna go to the properties. First of all, I'm gonna clear my database. So database, I'm gonna will use a dynamic value for this. We are using choosers to determine our current state of the player, if we are moving or if we are not moving. Based on that, we stack different databases. So I'm going to set it to dynamic value. Blend time, I'm going to set it to 0.35. Blend profile, if you go into the skeleton, we have the blend profile fast, feed plus root weight. So we are blending root fast and feed as compared to the different bonds. I'm going to set it to fast root plus root weight. You can also disable this if you like. Now we need blend to set this blend to this. I'm gonna jump the threshold time. This will be the 0. Pause, reselect history, search total time. Just set this variable to values to default. And we need one more important value, which is play rate. Set it to 0.8 to 1.2. Next thing would be, yeah, that's it, I believe. We don't need to change anything else. This should work. So now we need a way to select our run start database, idle database, run stop, so that we select multiple databases based on our current game condition, and based on that we play the desired animation. As we have the run starts database setup, I'm gonna create a new database with motion matching PoseSearch database. I'm going to select the same schema for search database. I'm going to use the idle one for now. For idle, I'm going to grab a single idle animation, put it into here. Idle loop, that's it. This will be my idle loop. I don't need to change anything in here. Just need to set the normalization set as well. And inside our normalization set, we need to add a new entry and put the idle inside here as well. Okay. So how do we know if our character is moving or not? How do we know if our character is running? How do we know if our character is walking? So we need this information. So we can use our velocity, acceleration, stuff like that to determine if our character is moving or not. So I'm gonna use a simple thing over here. We have this information already available inside our character blueprint. What I will do extra here is go to the data. I have added a new in. If I remove this, I will create a new enum. I'm gonna go to blueprint enum. I'm gonna e_locomotion state. Okay, so we let's say we have currently idle, walk, run, sprint, these different states. I'm gonna add different enums. We are in idle state, walk, run, or sprint. These are two different states we can be in. So I'm gonna go to the sandbox character. Inside our tick component, we have this update movement, and inside here we have the desired gate. I'm gonna use the same function to set my locomotion state. Just a moment. I'm gonna create a new variable over here, locomotion state. Category will be the locomotion state. So if we have any input, then proceed the logic. If we don't have any input, if we vector length is greater, which means we have the input. Otherwise, we set the locomotion state to idle. If we have the input, then what we do is proceed the same logic, and it outputs different states: sprint, run, walk, etc. So we will use our variable over here. Sprint should be sprint. Walk should be, sorry, run should be over here, run, and walk should be walk. Run will be the run, and the last one our walk. Okay, so we are setting up our locomotion state based on this current character state. Now we need this information inside our animation blueprint. So I'm gonna create a new function, update essential properties. This will be our thread safe. So we need different properties like velocity, acceleration. So I'm gonna quickly use my nodes over here, update essential properties. I'm gonna copy paste few things from here to here. Acceleration. So in order to get our acceleration, we will use property access, player CMC, acceleration. We can get this value from here, promote it to a variable acceleration. This will be our acceleration last frame. And if our acceleration have some value, we have has acceleration, that's done. Similarly, I'm gonna use the same over here from player CMC, player character movement component, velocity. We have our velocity should be this, promote it to a variable last velocity. There we go. velocity, velocity, speed. If we get the velocity length, vector length, we have the speed. If our speed, let's say, is greater than 5 units, we have the velocity. If we have the velocity, then we can use this promote this variable last non-zero velocity. So we have few different variables set up. I am gonna promote it to a separate category, essential variables. Acceleration has acceleration, velocity. So I have these variables inside in a separate category. So these are few variables we need. Now we need, let's say I'm creating a new function, update states. Update states. This will be also thread safe. So the state would be our. You can put the same. You can put the this inside the same function as well, like essential properties. But I'm gonna use a separate function. So player character, if I'm gonna grab the locomotion state, I'm gonna promote it to a locomotion state. Locomotion state, like so. I'm gonna use another variable, last locomotion state. Last locomotion state will be my current locomotion state. Put this to same essential variables. Okay, so now we have our states are set up. We need to call these functions. First we will use essential properties, then we will update our states. Now if I hit play, if I print something like current locomotion state, let's say, you can see I am in idle. Now if I move, I'm in run, idle. If I press caps control, I am in walking. If I press sprint, I am in sprint state. So our different locomotion states are available inside our animation blueprint. So we need, now we'll use this information and select the database based on this information. Okay, this thing is done. Next thing, our choosers. So I'm gonna open this motion matching data assets, create a new folder, chooser. Our last important thing, animation, motion matching. No, we need a chooser table. So we need animation chooser. The animation, we need to select the animation class. So we have this sandbox vector, animation chooser, create. I'm gonna call this chooser table, cht underscore, let's see, just a moment, PoseSearch database, PoseSearch database. This is my chooser first. So inside my chooser will only output and input both. It will also take the input from the, so struct parameter, I'm going to delete this. We don't need to currently set this up. So we will only output our animation databases, and we will also take the input from animation blueprint. Okay, so if I add a new enum over here, let's say, you can see we have set up the animation blueprint for this chooser, And if I go to the if I go to this, we have our locomotion state already set up. Now we need to add a row. Column, our locomotion state is a column, and our will add a row. Asset. Wait, I don't need this, as I need a nested chooser, and I'm gonna call this new nested. I'm gonna select the new nested chooser. I'm gonna call this. So these are our standing version, stand, idle. So inside our stand idle chooser, we will have our stopping, idle, turn in place, different transition from crouch to stand, stand to crouch, these transitions. So if I open this, so this we will select this row if our locomotion state is idle, right? Now if I edit this again, and we only have one item, so I'm gonna add that into over here. So we only need a PoseSearch database. We don't need whole different assets over here. So now if I add an asset, we only have the database. We don't have the different animation sequences, montages, stuff like that. We only need databases. So that's why inside the settings, table setting, I have only result class would be set it to PoseSearch database. So if our locomotion state is idle, we will select this. Now if I duplicate the same, if our locomotion state is run, we will create a new nested chooser. I'm going to call this run and run. Inside here, if I add a new row, asset, will have our run starts only. So this is our pretty simple chooser. It will take our locomotion state. Based on that, if we are in idle, select this stand idle. If we are running, we stand run. Simple. Now if I go to the animation blueprint, animation graph, we have set this database to a dynamic value. Now on our own update, create a binding. Let's update. I'm gonna call this this one, on update motion matching. We'll use a separate category, motion matching. So we have this function bind to this motion matching node. So whenever motion matching node runs, we will call this function. So we have this motion matching node. I'm gonna convert it to the motion matching, convert to motion matching node. And first of all, we need to run chooser, evaluate chooser. We will evaluate our chooser table. We will get our all results from the chooser and select this chooser. We only have currently one chooser, PoseSearch database. Our reference to self. So this will evaluate our chooser, and the chooser is already defined over here based on the locomotion state. This will output our different databases. Let's say we are in run state, this will output our run databases. If we are in idle, this will output our idle databases. So I'm gonna set databases to search, set databases to search over here. These are all our databases and output over here. I will set the interrupt mode to do not interrupt currently. Now if after setting this up, you can see our character is in now an idle state. Okay, now if I hit play, Here you can see we can run start and then go to the idle. Pretty cool. See? So we already have a functional motion matching setup, which is only for running. We'll definitely go to the deeper details for So I'm gonna start setup. So before ending this tutorial here, I'm gonna add a run stop database as well, so that our run functionality looks functional inside our animation database, motion matching database. Okay, for our stopping, we need we'll create a new schema. PoseSearch schema underscore stop. Okay. So we need to prioritize our trajectory. So I'm gonna simply put the weight to 5, so that it will prioritize our trajectory weight as compared to the different other channels like position channel and velocity channels. Create a new database, motion matching, PoseSearch database. Select the schema, PoseSearch database, PoseSearch schema underscore, PoseSearch database underscore run stop. That's it. So if I open the animations, we have different stop. I'm gonna grab all my stops, put it into the run stop. See, we have all different stops are in the database. Set this disable this selection, and for let me open it up. Run stop. So we have this run stop, and we need to put obviously the normalization set. Normalization set would be, we have run starts and run idle. I'm gonna put a run stop as well over here. So our run stop pose database is all set up. Now we just need to add this into our chooser table. Obviously, I'm gonna go to edit, add a new row, run stop, and now let's hit play. See, our run stops are also playing. So at least our run is totally functional. Obviously, we will go into deeper details and set this up properly. So that's it for this video, guys. I hope you like this, and I will see you in the next one. And in the next videos, we will gradually build the system, as we already discussing in the start. We will deeply cover all the details and try to push this to the gameplay animation sample demo from ground up. So I hope you guys like this video, and see you in the next one. Bye.